Hey Finxters! Today we will be learning how to remove specific elements in a NumPy array. So let's try to understand this question with the help of an example. Let's say that this is the given array which has the elements 10, 20, 30, 40 and 50. Now we want to remove the elements 20 and 40, or we can also say that we want to remove the elements which are at the index 1 and the index 3. So when we go ahead and delete these elements, we will be left with the elements 10, 30 and 50 in the resultant array, and this should be our output. So without further delay, let us dive into the different methods that will help us to solve this problem. So the first approach that we will be using to solve this question is to use the delete method from the NumPy library. Simply put, delete is a method of the NumPy library that deletes elements from a NumPy array based on a given index or position. So let's try to understand how the delete method works with the help of an example, which will help us to solve this problem. So our first task is to go ahead and import the NumPy library. So that is what we have done here. Import NumPy as np. Now here np is the alias used for NumPy. In other words, we will simply be using the short form np to denote the NumPy library. Now let's go ahead and create the given array. So this right here is the given array, which consists of the elements 10, 20, 30, 40 and 50. Let's print arr. So there we go. We have the elements 10, 20, 30, 40 and 50 within the given array, which is arr. Now let us go ahead and let's use the delete method from the NumPy library, which will help us to delete the elements 20 and 40 from this given NumPy array. Before we do that, it is important to understand that there are two ways in which we can remove the elements from this array. The first way is when you know the elements that you have to delete from the array. That is, the elements are already known. And the other condition is when you do not know the elements which you have to delete, but you know the position or the index of the elements in the array which have to be deleted. So let's first deal with the condition wherein we know the index of the elements to be deleted. So let's say that we have to delete the elements from the indices 1 and 3. So let's store these indices within a list which goes by the name indices. Now let's create the resultant array which will store the output. So let's say that the name of the resultant array is new_arr. Now all you have to do is to use the delete method from the NumPy library. So np.delete, and within delete you have to pass couple of parameters. The first parameter is the given array from which you want to delete the elements. So the given array is arr. And now the second parameter will represent the indices which you want to delete from this array. So those indices are stored within this list, which goes by the name indices. So let us simply go ahead and pass the list indices. And that's it. As simple as that. All you have to do now is to go ahead and print the resultant array, which is new_arr. Now let's go ahead and execute this piece of code to find out if this works or not. So there we go. As you can see that the output array has the elements 10, 30 and 50, and the elements 20 and 40 have been successfully removed with the help of their indexes. So what we did was to simply use the delete method of the NumPy library, and then we passed the given array, which is arr, and then along with the given array, we also passed the indices from which the elements have to be removed. So this brings us to the next condition wherein we already know the elements to be deleted from the array. And in this case, the elements that have to be deleted are 20 and 40. Now here we need the help of another NumPy library method, which is np.where. So np.where is a method of the NumPy library which allows you to select certain elements from a given NumPy array based on a specific condition. Now in this case, the condition is simply an expression wherein we have to define the elements 20 and 40 within the where method so that the delete method can then delete those elements. Now to understand this, for the time being, let's consider that we only want to delete the element 20. So in that case, within np.delete, you have to pass the method np.where, and within the where method, you have to pass the condition. Now the condition here is when an element within ARR is equal to 20. So in that case, that element will be deleted with the help of the delete method. So let's go ahead and find out the output. We have an error. Okay, I forgot to pass the array or the given array within the delete method. So the first argument is the given array, and then the second argument is the np.where method within which we have to specify the condition. Okay, now let's execute this once again. And there we go. As you can see that the element 20 has been removed from the given array, and this is the resultant array. Now our task is to remove both the elements 20 as well as 40. So to do that, all you have to do is to make a slight modification within the condition that we provided within the np.where method. So not only do you have to delete the element 20, but also you have to delete the element 40, and that can be done using the OR operator. Once again, specify the next element, which is 40. So this tells Python that the elements 20 and 40 from the array ARR have to be deleted, and then the array has to be returned. So let's go ahead and find out the output to this code. And there we go. As you can see that we have successfully removed the elements 20 and 40. So this is how you can delete or you can remove elements from a given array using the np.delete and the np.where methods. Now an advantage of using the np.where method is, let's say we want to delete all those elements which are less than 30. So that means we want to remove the elements 10 and 20 from this array. So this is how you can specify the condition wherein we are specifying that the array will only contain those elements which are greater than 30. So that's it. Now let's go ahead and execute this code. And there we go. As you can see that we have a resultant array which has the elements 30, 40 and 50, and those elements which are lesser than 30, which are 10 and 20, have been successfully removed from this array. Well, this brings us to the next approach which will help us to solve this problem. And the method that we will be using in this case is known as setDiff1d. So setDiff1d is a method of the Numpy library which compares two Numpy arrays and then returns the unique values from those two arrays. So let's say that we have an array A which has the elements 1, 2, 3 and 4, and then we have another array B which has the elements 2 and 4. Now when we use the setDiff1d method on these two arrays, then it will compare A and B, and after comparing A and B, it will find that the elements 2 and 4 are already present in the array A and B. So it will eliminate those elements and return those elements which are not present in both the arrays, which are 1 and 3. So we are going to use this functionality to solve our problem. So let us find out how we can solve this using the setDiff1d method. So we know that we have to delete the elements 20 and 40 from this array. So let's go ahead and create another array which will store the elements to be removed. So let's say that the name of that array is ARR_removed. So let's create the array with the help of the Numpy library. So np.array, and let's pass the elements 20 and 40 within it. So now ARR_removed represents the array which consists of the elements which have to be removed from the original array. Now when you go ahead and compare these two arrays, you'll find that 20 and 40 are present in both the arrays. So when we apply the setDiff1d method on these two arrays, then these elements 20 and 40 will get removed from the original array, and what will remain is 10, 30 and 50. So we are simply comparing the original array with another array which consists of elements that have to be removed from the original array, and then returning the unique elements such that the unique elements will only be those elements which we want in the resultant array. So let's go ahead and implement this setDiff1d, and within this we have to pass both the arrays which are ARR and ARR underscore removed. Well, that's it. Now all we have to do is print new underscore ARR and that's it. So let's execute this piece of code. And there we go. So as you can see that we have the resultant array. Now please note that a problem with this method is that the output will always be sorted when you use the setDiff1d method. So let's say that this array has the elements in the following order such that we first have the value 60, then 20, 30, 40 and 50. And now let's say that we want to maintain the order after deleting the elements 20 and 40. That is, we want the output to be 60, 30 and 50. But in that case, if you use setDiff1d method, it will not work since setDiff1d method will sort the output in ascending order. So let's execute this piece of code to find that out. And there we go. As you can see that setDiff has sorted the remaining elements in the ascending order and the output is 30, 50 and 60. So if you want to sort the output after deleting the elements, then this can be the method which will work perfectly fine for you. Otherwise, if the elements are not already sorted within the array, then you might avoid using this method to solve this problem. Now, in order to avoid this problem of sorted output, we have another solution. So let's have a look at that solution. So the next method which will help us to solve this problem is the isin method of the Numpy library. Now, before we dive into the solution, it is necessary to understand how the isin method works. So the isin method returns a Boolean array by comparing one array with another array which have different elements with different sizes. So let's try to understand this with the help of an example. So let's say that we have the following piece of code wherein we have two arrays which are ARR underscore 1 and ARR underscore 2. Now ARR underscore 1 has the elements 10, 20, 30, 40 and 50. So it has 5 elements, while ARR underscore 2 has the elements 10, 30 and 50. So it has 3 elements. Now we are going to use the isin method and pass the two arrays which are ARR underscore 1 and ARR underscore 2 within the isin method. So what isin will do in this case is that it will compare ARR1 and ARR2. So it will find that the elements 10, 30 and 50 are already present within both the arrays. So it will consider the size or the length of the larger array and return true for those indices wherein the elements are same. So that means at index 0, the output returned will be true, whereas at index 1, the output returned will be false. Then again, at index 3, the output returned will be true. And the reason is 30 is present in both the arrays. So the output in the second index will be true. Then in the third index, the output will once again be false since 40 is not present in both the arrays. And then finally, in the fourth index, the output will once again be true since 50 is present in both the arrays. So let's execute this piece of code. And there we go. As you can see that the output is exactly as I explained. It is true, false, and true. So we are going to use the output returned by the isin method to solve our problem. Now, once again, we will deal with couple of conditions. The first condition is when we know the index of the elements to be removed. And then the next condition is when we already know the elements that have to be actually removed from the given array. So let's say for now, this is the given array. And let's say we already know the elements that have to be removed. So the elements that have to be removed are, let's say, 20 and 40. So these are the two elements that we want to remove. So according to what we learned, the output in this case should be true for elements 20 and 40. So when we pass this output or this Boolean mask to the original array in order to derive the output, only those values for which the Boolean mask is true will be returned. So what I mean is, let's say that res stores the output of the isin method, which compares the arrays arr underscore 1 and arr underscore 2. And now let's say that we passed res within arr underscore 1. So let's see what happens when we do this. And as you can see that the output is now 20 and 40. So let's try to understand this with the help of a few steps. So let's say that the first array was this. Then let's say that the second array was this. So when both these arrays were compared by the isin method, then this is the output that we got. And now when you feed this output to arr underscore 1, which is the given array, then this will return only those elements for which the Boolean mask is true. So these are the two values which will be returned as an output. But we do not want this. We want exactly the opposite of this. That means we want the values which are not true in this case. So in order to deal with this situation, what you have to do is simply go ahead and negate the output generated by the isin method. So this is how you have to negate the output generated by the isin method. And when you do this, this will generate an output which will look something like this, wherein Boolean mask will be true, then it will be false, then it will be true, then false, and finally true once again. And then those elements for which the Boolean value is true will be returned as an output. And then when you pass this Boolean mask within the given array, it will return those elements which are for which the Boolean value is true. So let's execute this and let's find out what happens. And there we go. As you can see that after negating the output of the isin method, 10, 30 and 50 are those values for which the Boolean mask is true. Hence, they have been returned as an output. And this is what we wanted. So this is how you can use the isin method if you already know the elements that have to be removed from the given array. Let's now discuss the condition wherein we will be given the indices from which we have to remove the elements from the array. Let us have a look at a demonstration. So let's say that this is the given array and these are the indices of each element within the array. Now we have to remove the elements 20 and 40, which are at the indices 1 and 3 respectively. So our first task here is to find the length or the size of the given array. So when we do that, we will find that the size of the array is 5. And we can find the size of the array with the help of the size method of the Numpy library. Now, once we know the size of the given array, then our next task is to go ahead and create another array which ranges from 0 until the length of the given array. That means the new array that will be formed will contain the elements 0, 1, 2, 3, and 4. So we can create this array with the help of the arange method of the Numpy library by passing the size of this array within the arange method. Now, if you have a close look, then you'll find that this newly formed array is nothing but an array storing the indices of each element present within the given array. Now our next task is to store the indices of those elements which have to be removed from the given array. So the elements which have to be removed are 20 and 40 and their indices are 1 and 3. So we are storing the indices 1 and 3 respectively in another array. So we now have two new arrays. One array stores all the indices of the elements present in the given array, while another array stores the indices of the elements which have to be removed from the given array. Now our next task is to apply the isin method on these two arrays. So let's try to understand what the isin method does. Isin method is a method of the Numpy library which compares two arrays and then returns a Boolean mask such that the elements which are present in both the arrays will yield the true Boolean value while those elements which are not present in both the arrays will yield false. So let's visualize this. When we compare these two arrays, then this is the output returned by the isin method. So if you have a close look, then you'll find that when you compare these two arrays, then the elements 1 and 3 are present in both the arrays. So when the comparison occurs, then the first element 0 is not present in both the arrays. So this returns false. Then the element 1 is present in both the arrays. So this returns true. Now the element 2 is not present in both the arrays. So this returns false. Once again, 3 is present in both the arrays. So this returns true. Finally, the element 4 is not present in both the arrays. So it returns false. The next step is to negate this output. And you'll soon find out why we have to negate this output. So we simply go ahead and negate this. And when you negate this output, all the Boolean values are reversed such that now the Boolean mask will look something like this, which is true, false, and true. It is now time to return the resultant array. And to return the resultant array, we simply have to pass this Boolean mask, the given array, such that only those values for which the Boolean value is true will be returned. So that means the Boolean value is true for the index 0, then it is true for the index 2, and finally it is true for the index 4. So the resultant array will store the values 10, then it will store the value 30, and then finally it will store the value 50. And this will be our output. So we now have to implement this logic within our code. So let's dive into our coding screen. So let's say that ARR_1 is the given array. ARR_2 represents the array storing the indices of the elements which have to be removed. And since we have to remove this element 20, which is at the index 1, and this element 40, which is at the index 3, so we pass these two values within the array. Now, our next task is to create another array which will store the indices of all the elements present within this array. Now, instead of breaking this down into numerous steps or into numerous lines of code, what we can do is let's create a variable res which will store the resultant array, and within this we can perform the entire computation. So our first task is to go ahead and create the array that will contain all the indices of all the given elements in the given array. So we can do that using the np.arange method, and then we have to pass the size of the given array. So this will create an array that consists of the indices of all the elements present in the given array. Now, as we learned in the demonstration previously, we now have to compare this array with the array containing the indices of the elements that have to be removed from the given array. So we have to compare these two arrays. So to do that, we are going to use the np or numpy.isin method. And within this, we have to pass both the arrays. So we have already passed the first array within the isin method, and then we have to pass ARR_2. This will return a Boolean mask. And as we learned previously, we now have to negate this Boolean mask. So let's negate this, and there we go. Now all we need to do is to pass this Boolean mask within the given array, which is ARR_1, with the help of the square bracket notation. And that can be done in this line of code itself. So ARR_1, and let's pass this entire Boolean mask within the square bracket notation. And that's it. All that remains to be done is to print the output, which is stored within the variable res. So let's execute this piece of code and let's find out if this works or not. So there we go. As you can see that we have the expected output displayed on the output screen. So this is how you can use the np.isin method to eliminate elements from given indices of an array and then print the resultant array. So that brings us to the final method of solving the given problem. So we will be using the in1D method of the NumPy library and then negate the output generated by this method to solve this problem. Now let's try to understand what in1D method does. It is a function of the NumPy library that compares two 1D arrays and returns true if the element in one array is also present in the other array. So this is quite similar to the methods that we learned previously. Now to delete the elements, you simply have to negate the output generated by the in1D method as we did for the previous methods. So let's quickly go ahead and implement the code and let's visualize the output. So this is the given array and the second array represents an array storing the elements which have to be removed from the given array. Now let's create a variable res which will store the output, and all we have to do is to use np.in1d, and within this we have to pass the two arrays so that they can be compared. So those two arrays are arr_1 and arr_2. Now this creates a Boolean mask, and we simply have to go ahead and negate the output generated by the np.in1d method. So let's do that. Okay, we have now successfully negated this output, and all that remains to be done is to pass this Boolean mask to the given array so that we can generate the resultant output. So we can do that with the help of the square bracket notation. So arr_1, and let's pass this Boolean mask within the square bracket notation. And that's it. Now let's print the result. So let's print res. And now let's go ahead and execute this piece of code to find out if this works or not. And there we go. So this is the expected output, and we have successfully solved this given problem. So we learned as many as 4 methods to solve the given question. I hope this helped you. And if you have any doubts, please mention them in the comments below, and I'll try my best to answer all your queries. Thank you.